We have an m by n rectangle. Square 200 is in the first row. Square 2000 is in the last row. We notice that 200 plus the average of 200 and 2000 is 1100. And I argue that if we join the center of square 200 to the center of square 2000, it will pass through square 1100. And if the slope is -1, it's going to pass through the two corners of this square. This is an interesting square to us because we are interested in the square just to the left of it, square number 1099. And we notice that if we pass through 1100 through these vertices, we are not going to pass through the interior of square 1099, but if the slope of the line increases a little bit, it will pass through the interior. So that results when 200 is a little bit to the left and 2000 is a little bit to the right. I drew 200 and 2000 arbitrarily. 200 can also be to the right of 1100, and we can draw a line that comes down here to 2000 on the left-hand side. It should be pretty intuitive that 1100 appears in the middle row. Let's number these rows. 1 is the first row, the last row is M. But if you don't believe it, and I had a little bit of difficulty assuring myself that this was true, let's just briefly show that 1100 is in the middle row. The last square has value mn. The row above that is row m-1. So this square has value m-1 times n. The middle row, because m is odd, the middle row is m plus 1 over 2. The row above that is m-1 over 2. And the value in this square is m plus 1 over 2 times n, the number of columns. And the value in this square is m minus 1 over 2 times n. And let's just briefly show that 1100 is in the middle row. That is, 1100 is less than or equal to m plus 1 over 2 times n, and greater than m minus 1 over 2 times n. So we're going to prove this. And we're going to do this, we're going to use the fact that square 2000 is in the last row. That means it's less than or equal to m times n, and greater than m minus 1 times n. We'll divide by 2 and add 100. Okay, so we have that our upper bound of 1100 is this expression, mn over 2 plus 100. And we want to find out when, if ever, is the upper bound of 1100. When does 1100 spill over into the bottom half of our rectangle? And that's when the upper bound is greater than m plus 1 over 2 times n. So we have mn over 2 plus 100, m plus 1 over 2 times n. Let's multiply by 2 and factor out n. So we have n is less than 200. This is a contradiction. 200 is in our first row. N has to be greater than or equal to 200 in order for that to be true. So we have a contradiction here, which means that 1100 truly is in the first row, or at least it doesn't spill over into the next row. I will leave it as an exercise to the viewer to show that it doesn't appear above the middle row, but it's the average, so it should be pretty intuitive that that is the case and not surprising. We also note that 2000 minus 1100 is the same thing as 1100 minus 200. That is, they are both a distance of 900 from each other horizontally, at least when the slope is equal to -1. They're always going to have an equal distance from each other. So there's symmetry in that respect as well. All right, so what we want to do first is see if we can find any restrictions on m, the number of rows. M is odd. and m is greater than 1. So why don't we start with some small m and see what we can do. Let's start with our next smallest m. M is equal to 3. And again, we'll use the fact that 2000 is in that last row. So it's less than mn and greater than m minus 1 times n. So when m is equal to 3, this chain inequality becomes 2n, between 2n and 3n. Split this up. Okay, so we have that n has to be odd. So our largest value of n from this part of the chain inequality is 999. We have 3n greater than 2000. So again, n has to be an odd integer. The next one is 667. I'm going to keep track of these. So now we have, if m is equal to 3, then n is in the set of consecutive odd numbers. The smallest is 667, and the largest is 999. Since we're counting mn ordered pairs, you can count these odd numbers up and you'll find that there are 167 values for m equals 3. Let's see what happens when m is equal to, well, m is odd, so the next one is m is equal to 5. So using, again, this chain inequality, that gives us 4n and between 5n. So here we have n is less than 500, but truly that's 499 since n has to be odd. Here we get n is greater than or equal to 400, but again, the next odd one is 401. So let's put that up here. M is equal to 5. N is in the set of odd numbers from 401 to 499. These are the odds only. So that is 50 values. Let's continue on. We're going to do m equals 7. That gives us 2000 is between 6n and 7n. N is less than. N is an integer. N equal to 285 and 5/7. The next odd number that's greater than that is 287. Okay, our smallest value, 287, and our largest is 333, odds only, and that is 24 values. This is a little tedious. M equals 9, 2000 is between 8n and 9n. N is less than 250, so the next odd number is 249. So that gives us 223 for our lower bound. So n is equal to 9. Let's see, our lowest number is 223, 249, again, odds only. So that is 14 values. Okay, let's see what happens when m is equal to 11. We have 2000 is between 10n and 11n. Here we have 10n is less than 2000. This gives us n is less than 200. Oops. That makes me sad because n has to be greater than or equal to 200 again in order for square 200 to appear in the first row. But the good news is that we can stop here. That's kind of nice. We've just narrowed down m to 4 values and n for some corresponding values of those. Let's take a look at m equals 3 because we can actually draw that out pretty easily. Let's see what this rectangle looks like with 3 rows I'm going to draw a part of that rectangle. This is going to keep on going to the left and to the right. This is 200. This is 2000. This is 1100. I arbitrarily put 200 to the left of 1100 and 2000 to the right, but 200 can also be here. I draw them so that the line that connects the center has slope 1 and -1. And I do that because that's sort of the limit on 2,200. When it passes through the vertices of our square 1100, let me actually put 1100 inside the box. There we go. That's box 1100. When it passes through this, it doesn't pass through our square of interest, 1109. It also won't pass through our square of interest if 200 is here and 2000 is here. Now, if we connected these squares, we're also not passing through 1109. However, if 200 is here, that puts 2000 over here, or likewise 2000 is here and 200 is here. If we connect these 2 points, we see that we do pass through this red square 1109 and vice versa. So we have this exclusion zone here where 200 cannot reside. If it's to the left, it's fine. If it's to the right, it's fine. But if it's one of these 3 values, then that's not allowed. And we can remove those values of n, those corresponding values of n, from our solution set. So let's see what we have here. How can we express this algebraically? This is actually square 1099. That's where my mistake was. Let's try that one more time. 1099 is equal to 200 plus n. N is equal to 899. This is disallowed. Let's take the other extreme, where 200 resides right above 1102. 1102, 200 plus n. That gives us n is equal to 901. These are 2 consecutive odd numbers. And so, the 200 in between them, which is also excluded, we don't have to worry about that value of n because we're restricting ourselves to n being odd. So we have 2 values that do not satisfy that. Let's take a look at our list of values of n. And in fact, what was it? 899 and 901, those are in our set. We can then subtract 2 from our 167 values, subtract the 2 invalid values. That leaves us with 165 values. Great. Let's continue on with n equals 5. Let's see if we can get an idea of a pattern so I don't have to keep drawing rectangles, but 5 rows isn't too hard, so we'll just give that a try. n equals 5. That's a rectangle with 5 rows. I'm not drawing the entire rectangle here. It keeps on going to the left and the right. So it keeps going in that direction, that direction. Let's connect at a 45-degree angle, this square and this square, and it's going to pass through square 1100. This is 200, and this is 2000. Let's fill in the rest of these grid lines. We add one additional row, then 200. When we have a slope of -1, 200 goes 1, shifts 1 to the left, 2000 shifts 1 to the right. So let's fill these in. 1099. This is 1098. And we also can't have 200 here or here or here or here. So our exclusion zone got a little bit wider, and likewise 2000 here. But let's express this algebraically. So what we do not want is we don't want 1098 to be equal to 200 plus 2 times n. That accounts for 2 rows to get to 1098. And we solve for n. That gives us 449. And then we also can't have it, let's see, it's 11. This is 1101, 1102. we can't have 1102 be 200 plus 2n. That gives us an n value of 451. These are also two consecutive odd numbers. So even though 200 can't be in these other three locations, they're either even or fractions. So we just have two values that we need to remove from our set of values, which is there. So I'll just subtract 2, and we're down to 48 values for m equals 5. I'm not going to draw the rectangle for m equals 7. I think we can just use this diagram. For m equals 7, 200 is going to be 1 over to the left, and it's going to be directly above square 1097. So my equation is 1097. We're going to exclude 200 plus, and then we're adding another row above the middle row, so that's plus 3n. And when we solve for n, 299. And then likewise, if we continue to the right, this one is 1103. We do not want 1103 to be equal to 200 plus 3n. That gives us a value of n is equal to 301. Again, two consecutive odd values of n, so we can exclude that. Let's see, 299 and 301, that's in our interval here. So let's subtract 2, that's 22 values. Let's see if we can estimate what we get for m equals 9. We're going to not want 200 to be 1 to the left of 1097, so that's 1096. 200, we're going to add another row here, so that's plus 4n. Solving for n, we get 224, which is even. And then if we go with 7 rows, we don't want 200 to be at 1104, just 1 to the right. So n is going to be equal to 226. But we note that in here is n is equal to 225. And that's probably going to be one of these other locations for 200. So this is just one value to exclude when m is equal to 9. It's in our interval. So we subtract 1, and we're down to 13 values. All that's left is to add these. We have 165 plus 48 plus 22 plus 13. That adds up to 248.